We'll begin this lesson by graphing the reciprocal of a linear function. In part A, fill in the table of values for the function y equals 1 over x. Bring up the table of values. Evaluate the function at the first four x values. When we divide by 0, the result is undefined. Complete the table by evaluating the function at the last four x values. In part B, draw the graph of the function y equals 1 over x. State the domain and range. Bring up the completed table of values from part A. Plot the points and draw the graph. The dashed vertical line is called a vertical asymptote. The graph can get infinitesimally close to the line, but will never actually cross it. The dashed horizontal line is called a horizontal asymptote. All reciprocal graphs with the form y equals 1 over f of x have a horizontal asymptote at y equals 0. Note that horizontal asymptotes are less strict than vertical asymptotes, and the graphs of complex rational expressions may cross the line. The horizontal asymptote is more of a trend line for the graph's end behavior. The domain is x belongs to the set of real numbers, with the restriction that x cannot equal 0. The range is y belongs to the set of real numbers, and the y value will never equal 0. In part C, draw the graph of y equals x in the same grid used for part B. Compare the graph of y equals x to the graph of y equals 1 over x. Draw the graph of y equals x. Now we'll compare the graphs. First, the vertical asymptote of the reciprocal graph occurs at the x-intercept of y equals x. Second, the invariant points that are identical on both graphs, occur when y equals positive or negative 1. Third, when the graph of y equals x is below the x-axis, so is the reciprocal graph. And when the graph of y equals x is above the x-axis, so is the reciprocal graph. In part D, outline a series of steps that can be used to draw the graph of y equals 1 over x, starting from y equals x. Bring up the graph of y equals x. First, draw a vertical asymptote at the x-intercept of y equals x. Next, draw the invariant points where y equals positive or negative 1. Next, identify the regions where y equals x is below the x-axis and where it is above the x-axis. And finally, draw the graph of y equals 1 over x and erase the intermediate steps.